Good morning, students. So today we are going to start a chemistry chapter, that is metals and non-metals. Okay, so before starting the chapter we shall know the history of metal through a short video clip. Just go through it and come back.
Early man used stones to make weapons, utensils, etc. He needed weapons to protect himself from wild animals and so on. So this was the Stone Age, in which the early man used stones for different purposes. But there is some problem with using the stone weapons. If they fall or some force is applied, these stone weapons, they easily break. So from stone, they then shifted to a different substance, that is wood. They started using wood for making different weapons. They could shape wood in different forms. They could make it really sharp. But again, the problem with wood is that it does not retain the sharpness. It also loses its sharp character when force is applied or by other forces. One day, while looking for stones along a river bed, they found some small pieces. When they tried to break it to form the weapons, they found that it did not break. Instead, it only changed its shape. So they were very happy to find this substance which does not break. So they formed different types of weapons using these substances. These substances that they had used were copper.
Students, how was the video? Wasn't it interesting? Yes, it is. Okay, so if you go through the video clearly, you will get the knowledge of how the metal has been evolved from ancient days. Okay, so now we shall continue the chapter, that is to know the physical properties of metals. Okay, so we shall know what are the physical properties of metals over here. So first thing, we shall know what about malleable. Okay, we have a first point, that is metals are malleable in nature. So malleable means metals beaten into thin sheets. Okay, metals beaten into thin sheets, that is called as malleable. Okay, the other property we know, that is a ductile. Ductile means metals beaten into thin wires, that is ductile. Okay, so I repeat, malleable means metals beaten into thin sheet. If you beat the metal, if that metal acquire the sheet-like content, then that property comes under malleable. Ductile means when you beat the metal, that metal changes its form into a wire. That is called ductile. Those are the two main properties, and the other remaining three properties are, they are strong in nature. Okay, metals are strong in nature, as well as metals are hard in nature, and also metals are lustrous in nature. Okay, now what is the lustrous? Lustrous means shiny. Okay, lustrous means it's a shiny substance. So we say that metals are strong in nature, metals are hard in nature, similarly metals are lustrous in nature. Now whatever the properties you can see here in the metals, this will not be present in the non-metal. Okay, so in non-metal you can just see it is a weak in nature, it is a smooth in nature, as well as it is non-lustrous. It's a complete opposite of all these three natures. Okay, so non-metal, we can say what are the physical properties of non-metals, that is they are very weak. Opposite of strong is weak. Here opposite of hard is soft. They are soft in nature, they are weak in nature, similarly they are non-lustrous in nature. So these are some of the physical properties of metals as well as non-metals. Now we shall see, so physical properties are done, right? So in the previous one I have already told you about the physical properties of metals. So now we shall start the chemical properties of metal. So in that first one, we are going to study about a reaction of metals with oxygen. Okay, where do we find oxygen? We find oxygen in the atmosphere, right? So what happens when metal reacts with oxygen? We shall see that. Okay. So first, can you see here Fe? Okay. Fe is nothing but it's iron. Okay. Fe is nothing but it's iron. So when iron is reacting with oxygen, O2 is nothing but it is oxygen. Okay. Iron, when it is reacting with oxygen, you obtain the product, that is ferric oxide. Okay. FeO2 is nothing but ferric oxide. So in the other word, in a common word, if you want to tell ferric oxide, it is nothing but rust. Okay. So usually we see that iron metal usually get rust when we keep it outside in the atmosphere for a long time, right? So when we keep the iron substance outside in the atmosphere for a long time, what happens is this oxygen molecule comes and attacks on that iron and there forms a brownish layer on the iron. That brownish layer is called as rust. Is that clear? So this is what the reaction of metal with oxygen. We shall see the second chemical property of metal, that is reaction of metal with water. Okay, the first property we have seen that reaction of metal with air, right? So this is the second property, reaction of metal with water. So now let us take an example of a metal like sodium. Okay, Na is a symbol of sodium metal. When sodium, I am going to react this sodium with H2O, wherein H2O is nothing but it's a water. Okay, so when you react the sodium with water, the product you obtain, that is NaOH. Okay, NaOH is nothing but sodium hydroxide. Okay, NaOH is sodium hydroxide plus, can you see a H over here with an arrow mark upwards? So that indicates hydrogen gas is released. Okay, so wherever if any element is along with an arrow mark which is faced towards upside, then that indicates that particular gas is released. Okay, so here H is along with the arrow mark, so we can similarly say hydrogen gas is released. So always remember, when the reaction of a metal with water takes place, for example sodium is reacted with the water, you will obtain a product of sodium hydroxide with the liberation of hydrogen gas. So next we'll go through a different type of reaction, that is displacement reaction. So before starting displacement reaction, you need to know about the reactants and products. Okay, so reactants means, students, can you see an arrow mark over here? Okay, now this is a chemical reaction. You can see from here till that Cu, that is a chemical reaction. Now this arrow mark indicates that makes the chemical equation into two different parts. Okay, this arrow mark is making one reaction into two different parts, wherein the first part, whatever you can see towards the left side of the arrow mark, whatever you can see, those are called reactants. Okay, reactants, and whichever the substance present on the right side of the arrow mark, those are called as products. Okay, students, so whichever the substance present towards the left side, that is called reactants, which is towards the right side, that is called as products. So now in simple words, displacement reaction means reactants displace and place in other position. Okay, so displace in the sense it changes its position. So here reactants changes its position. So whenever in any reaction, if reactants are changing its position, then such type of reaction we call it as displacement reaction. Okay, so what is displacement reaction? So in reactants, what happens? Reactants change its position, then such type of reaction is called displacement reaction. So now we'll have a small example to make you clear what is displacement reaction. So here CuSO4. CuSO4 is nothing but copper sulfate. Okay, so copper sulfate, I am reacting this copper sulfate with a metal, that is zinc. Zn is zinc. Okay, copper sulfate is reacting with the metal zinc. Here what happens is, can you see here this SO4 is there now? It is along with whom? It is with the Cu, right? SO4 is along with Cu, but can you see the changes over here? Here SO4 is along with Zn. Now what became empty? Cu became empty. So now whatever here SO4, it was along with the Cu. Okay, in the reactant side. So when it is shifted towards the product side, what happens? This SO4 combines with Zn to form zinc sulfate. Okay, it becomes ZnSO4. It becomes zinc sulfate. Now here Zn was empty. Zn was alone in its position, right? Now when it comes to the other side, Cu becomes alone. Why Cu becomes alone? Because whatever substance was along with the Cu, that joins with the Zn. So Cu becomes empty here. Okay. So this type of reaction, we call it as displacement reaction. So this is the last topic, students. Now we shall discuss the uses of metals as well as non-metals. So first of all, we shall discuss some of the uses of metals, okay, where the metals is used. So first thing, they are used in the preparation of several items. So first one is the utensils, okay. Metals are specially used in the preparation of utensils, window panels, okay. In panels of window we use metal, that is iron. And jewelries also we use metal, gold, silver, platinum, all those are metals. And also in some of the chemical experiments. So if you want to prepare any few of the chemical experiments, so for that experiment also we use some metals, okay. So these are the uses of metals. Now coming to the uses of non-metals, the first point say it is used in the purification of water, okay. Some metals are suitable for the purification of water. So for that reason, in some AquaGuard and few of whatever brands, purification of water brands, they use a few non-metals inside those equipment, okay. So that is a first point. And second point say it is used in fertilizers, especially in fields and all agricultural fields, we use non-metal as a fertilizer, okay. So that is the second point. And the third one say it is used in the preparation of antiseptic, okay. So antiseptic we obtain in medicals. Doctors prefer antiseptic if any wounds are present in hands or legs or overall in your body. Antiseptic is used, right? Antiseptic ointment will be used. So for the preparation of those antiseptic ointment or any antiseptic related tablets, non-metals will be used, okay. So these are few of the uses of metals as well as non-metals. So here ends the chapter metals and non-metals.